Good afternoon. My name is Alexey Smirnov. I represent Racurs. So I want to make a presentation on unspecialized UAS for mapping. What's the purpose of this presentation? We're getting a lot of letters from companies that are planning to use such system or are already using them. And the first question that comes up, actually there's a lot of questions, and Racurs is a proponent of specialized systems, so we give them a word of caution. But those who have already purchased those unspecialized unmanned aerial systems, we try to help them out the best we can. So in my presentation, I am going to talk about what my understanding of unspecialized UAS is. What are the prerequisites for using it? I mean, why do they purchase it? Why do they use it? What are some misconceptions on the part of buyers? I mean, they receive some information which prompts them to buy it. Then we're going to share some experience of aerial survey materials, and then we'll try to make conclusions. Is it worth it or not? So what is an unspecialized unmanned aerial system? I tried to group these systems in three categories. Category one is what you can purchase around the corner on the street, typically costing $50 to $500. This system can lift up in the air and carry a certain piece of equipment like camera. Second group is DJI vehicles. A 9% share of popularity is associated with DJI, therefore a dedicated category for them. And the third group are unequipped vehicles that you can purchase through eBay or AliExpress, but they don't have any payload. When you buy it, you can make adaptations to tailor to meet your needs. But those who purchase those systems, mappers and land surveys, do they have the proper qualifications to make adaptation? Typically, no, because they're not designers, not engineers themselves. Second question is why? Prerequisites for use. The main reason is cost effectiveness. I mean, they are the cheapest, rather economical. This is the primary driver for such purchases. Typically, smaller companies or private entities do not have money to buy a fairly expensive specialized system. So they are tempted to buy a cheaper product because it is supposed to give the same results. These are the all-in-one systems which you don't have to assemble on your own. You don't need to have an engineering background. And thirdly is the grapevine thing. I mean, someone has purchased it, and then a friend of his will go to him to check if it was okay. And whoever bought it is not going to share the inefficiencies and failures of the system they purchased just to save embarrassment. So how do they really operate? Typically, there is a question and an answer, and these are the questions ordinarily asked by those sitting on the fence. The first one is sensors. Whoever advertises that says, they talk about how much time it is going to operate and what's the reliability, time to failure. For aerial photography, these two parameters are very important, but not the key ones. We're interested in the ultimate result, and the result is aerial photography. And aerial photography is driven by sensor. None of the users ever use questions about sensors, and they end up in a tight spot later on. The second one is that recently there's been an idea to mount professional GNSS system for accurate georeferencing. Those who did mount, they say now all problems go away. But if we look at item 1, it turns out that not all the problems go away because sensors and GNSS systems are not connected in any way, and they exercise no impact on one another. And the third question, well, you've taken of image quality and accuracy, and you immediately pack it into a photogrammetric system to generate result, and you begin to control it yourself. When the results are good, no questions are asked. But if the results are poor and bad, then they cannot fix it. And the first thing they do, well, first thing you gotta do is to pre-control the results, which means quality and geometry. And again, we loop back to question number 1 about sensors. Let's imagine we have poor result. Who do we go to? Who do we bring our complaints to? No one, because we purchase it at the convenience store, and if you bring it back, they're unlikely to refund it. So next thing you do is you call the manufacturer, and the manufacturer will shrug shoulders, say, why are you using this for such serious tasks? And official usage requires certain permits, and
usually they start using it without any permits, thinking that in principle this is an inexpensive system that they can buy in a shop and can be used by any child, so no permits necessary. But the main problems appear in the actual results of aerial photography. Any aerial photography in Russia is considered to be confidential, no matter what system it is published by. Now let us look at the results. This is just an example of many people who simply came to Racurs with their questions about the problems that they experience. I will tell you about the results of imaging of the DJI satellites, because DJI hardware, and I will tell you model by model what the results are. First model, the lightweight, least costly DJI Mavic, and the quality of this imaging is more or less good, although there are blurry images in some of it. But the main problem with this model is that the camera uses electronic shutter, rolling shutter, and as a result, with a high speed, we can have serious shifts and the distortions of the objects themselves. Now, Phantom is one of the most popular one in the world. Phantom range and the examples of aerial photography, metric aerial photography, start to appear with the use of the Phantom 2 with the GoPro camera, and it had fisheye lens on it. I'm not going to tell you more about it. You just look at it, at the geometry of objects on this image. You can see that the nadir part of this image in the center, all other things are located, and so with sort of high perspective, even if you triangulate and transform them, it's unlikely that you will get anything good out of it, especially when you try to measure some centimeters there. I wouldn't recommend that for sure. Next, some of the most popular models are DJI Phantom 3 Pro and 4 Pro, and reliance-wise they're about the same. They're different in cameras, and in the first one, initially it was a camera with a smaller matrix and a smaller and central shutter, just like all the parameters look to be nice for aerial imaging, but as a result we'll get results which are not really stable or consistent. Look at this example. It shows many images, about 125 images, different days, different weather conditions. You can note here different brightnesses, different radiometry within the same flight, And results, this result in should be, in theory, photogrammetrically rectified automatically. But what if you're not happy with the end results? Then what will you do? You will have to redo the whole imaging. So another important thing is that in Phantom 4 Pro version, what people are already using, we switched off the focal length fixing. Why? DJI did this because they realize that they are using this imaging not for photographing of the location as a photo. They use action video cameras, rather video flow, which must be captured in high quality with high detail level, and we're suffering from such things. Next, more powerful systems, Inspire class systems, and it is equipped with the mountable cameras specifically developed for DJI, and one of them is called X3. All the samples that I have from this camera are bad, captured by different people, different sensors, different carriers, but all bad. Within one flight we have different level of detail on the images. Just for your information, let us measure the size of blur on the worst image. It looks like 24 pixels a priori. It means that even before processing, 24 pixels would be your error level, even before you start processing it. Next, the same carrier but with a different camera, better, camera X5S. Here we have the following story. Here they were acquiring an image of a house, quite detailed image, and most of the images were okay until a certain moment in time. At a certain point in time, it went out of focus. All the objects were out of focus, all the subsequent images started to look exactly like this. What happened then? Nobody knows. Neither the executing agency nor the ones who were processing this imagery. So basically the result could get distorted and could get out of focus, and we couldn't expect it. Another carrier with the same camera, an example of this, a good image, good detail level. It's not orthophoto, but the original block scheme showing the quality level. No real complaints about this, but the same hardware and the same camera on the next image shows that here at the top part of the image you can see non-realistic colors. Radiometry is lost. Why is it happening? Nobody knows. And basically the same site with the same camera on the other day, and we see totally different results, which could not be predicted by anyone. And the reasons why it happened like this, nobody knows. Next option, Matrice. Matrice range. DJI positions it as metrical engineering imagery. They are not saying that it is cartography imaging, but metrical imagery to monitor different objects like bridges and so on and so forth. But Matrice 100 and X3 camera. So they did mapping imagery of an area on different days. You see different differences in brightness and again the quality of the imaging within one single flight. You can see that level of detail in different swaths can be different on the same object. So basically, again, it's very hard to predict the quality here. There is yet another model which potentially can be is adoptable. It's 600 Pro. Why this one? Because its its payload capacity is 15 kilos. 15 kilos means that we can mount good camera with good gimbal and good GNS system. But if we look at profit at the actual price of such a system, then we understand that it's going to cost from $10,000 onwards. So for $10,000 we're buying something that we cannot guarantee. Yes, we have adopted it. It might be okay, but still nobody can guarantee it, neither us nor the manufacturer. And if we look at the highly specialized instruments manufactured both in Russia and other countries, we can note that highly specialized hardware with the same equipment can be bought at a much lower price point, and it's no longer reasonable to buy the system because of economic reasons. Now, the conclusions of everything that I've mentioned. First, can we use the systems, such unspecialized systems? Yes, you can. Why not? You have seen the quality could be good, could be bad, but the worse is the quality of the source information, the more field work we'll have to do, more ground control points, more interpretation. And I would like to announce a presentation about local success of work with the systems from Dr. Yanis Yanidis. He's going to make this at the next panel. He will speak about his experience using such systems on local projects. You will see how those results can be acquired to make sure that it's good. At the same time, the results are unpredictable, highly unpredictable. If we use these systems, we can get both good and bad results, and we will never be able to know or predict it beforehand. The main difference between specialized and unspecialized systems is how it is autopiloted, because aerial imagery is done based on the set of rules. The actual carrier and the camera must not work how it can, but how we want it to work, and the rules have been written before us. And consequently, if we use non-specialized hardware, if we don't like something, there is nobody to complain to. In other words, we have no guarantees. For this report, I would like to thank the organizations on this screen and some persons who shared their results with us, who helped me with testing, in organizing a discussion and submission or sharing huge experience on how to use the systems. That's it. Thank you very much. Thank you. So, we can still have time. We still have time for one question before the launch. If there are no questions, then no, we have one question.
Hello. Thank you for your presentation. It's very useful. I'd like to ask you if you have think to calibrate the original camera based the unspecialized UAVs.
Окей. Я по-русски отвечу.
If you have, then the elaborate calibration, if it could improve the result, the accuracy. Thank you.
Да, действительно.
Yes, indeed, we did test calibrated those cameras, but the thing is, if the camera has all the internal orientation parameters, you can calibrate whatever you want. Even iPhone can be calibrated. But as I mentioned, in some models, there is no fixed elements of internal orientation, which means that we can do some calibration, we'll get some results. But at the same time, when we apply this to the project, the camera can change its parameters, so basically the calibration won't help. In other words, each time we'll have to do the same calibration of the photogrammetric system and pray for it to work well, because it might work well, but it might not work well, and we cannot predict it beforehand. Thank you very much. One more question. Did I understand you correctly in terms of your conclusions that on an unspecialized hardware and cameras one can get good quality results, but it's the issue of luck or high professionalism, but when doing mass production, you categorically do not advise to use unspecialized hardware? That's right. That's my conclusion. Yes. Just like you said. Because when you end up with the big volumes of data, there is a high probability of getting a lot of problems. So why do we need all these problems when you can buy specialized hardware and do everything well? I guess everybody's hungry now. Just 1 minute. I would like to use this opportunity to announce my masterclass where I can tell you in greater detail about all our experiences and projects and show you some real examples. Okay, now I announce launch hour. Thank you, Andrei. We'll be regrouping at 2 p.m.